Good evening. Um, I haven't really done a lot of videos lately because, quite frankly, Flat Earth is really boring now. The final experiment has killed it. Only people who don't really learn are still hanging about. And I got better things to do. And I've noticed a lot of globies have jump ship to. A lot of people are bored. But once in a while, I have a look. I mean, with the Artemis, flying around the moon recently. It's another nail in the coffin for flat earthers, but they still stick their head in the sand and think that it's a bloody win because if they call fake and if they go and create AI pictures, which is making fake images, that they can use those fake images to say that it's false. Fancy that. Fancy them saying, oh, fake, it's fake. But they're the ones who are going out there creating AI images of the Artemis mission and then saying it's real. So who's the one lying here? Anyway, I noticed recently that the Globebusters guys, Alan, good old fucking Alan, Shane, and Stone, who's the most arrogant fucking dickhead in the fucking world. He's so fucking arrogant. It's just wrenching to listen to the fucking cunt. They were going on about this stellar aberration and their experiments, and I looked at it and I thought, you know what, that's kind of interesting actually. It's actually kind of interesting. I'd like to see what it is because most of the photos I was seeing online were very blurry, very hard to see, and even this video is very blurry and hard to see. I must admit, we can't see the data. Yeah, I mean, they have some data that they display, but how can I see the data for this? I can't see a link here. I'd like a link. How can I get a link to be able to actually dive deep into it and actually have a look? Because at the moment, I've got blurry photos. And I can't look closely enough. And I must admit that on many of these graphs, it's hard to actually figure out what the Z, the Y, and the X axis actually is. Some of these axes are actually not marked at all, so you can't tell how high or how far across things are. So we need the data, guys. And your links in this video are a whole bunch of unrelated stuff. It's not to do with this experiment at all. Not that it's an experiment, but it's an interesting data thing, which I never would have bothered to do personally. I couldn't give a fuck. But Stone's obviously gone out there to do it, and he thinks that it debunks heliocentrism. He keeps saying that this is the nail in the coffin for heliosexuals, which it's just like, it's just disgusting to listen to personally. I mean, yeah, you think you're cool, honestly. You just sound like a faggot, honestly. I'm going to beep that out. Anyway, so when I had a bit of a look at this thing, so the first one was the cylinder drawing, right? And I can see that this red line indicates just the way that essentially, in a lot of ways, if you look at as a glober, I can see that what that actually is. That's the 23-degree tilt of the Earth, because as it goes around the Earth, around the Sun, it tilts 23 degrees down and it tilts 23 degrees up, right? And then in September and March, that's when the equinoxes happen. That's where it passes the equator. So I can already see that this is a globe proof right in front of me, and it's not a flat Earth proof, guys. Not a flat Earth proof at all. Maybe geocentrism, maybe, but certainly not flat Earth. The other thing that I can see on this particular graph is you see everything in the red section, the south section, right? All the little rings, right? They all point downwards. So the stitching is on the top side, and all the rings are on the bottom side. All the ones which are next to the red line are straight lines, and all the ones above, the stitching is on the bottom, and the rings are on the top. Perfect. That's great. As far as I'm concerned, that looks good from a heliocentric globe perspective, actually, because one is displaying that everything's facing south, and the other one's displaying everything facing north. I don't know how you would, come to, say that this is flat Earth proof at all. So I'm going to accept this is great, fantastic. Thanks for this, Stone. Another close up, as you can see. If you look closer, you can see the rings are all pointing to the bottom. And mind you, he did say that most of this is condensed inside the black dot, which, fine. I completely agree. When I first looked at these screenshots on Twitter, I thought, holy shit, they're really, really fucking long. They're like way, 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 way long. But, as he said, it's only inside the black dot, so I'm perfectly fine with that. That's good. Okay, I'm completely agreeing. Okay. Once again, another zoomed in one. You can see that this red line comes up, and that's obviously that's when the tilt is going up. To be honest, I don't 100% know if that's Australian summer or if that's the American summer. It probably is the Australian summer, to be honest. And by the way, he keeps on calling this star Betelgeuse or something like that. I mean, what the fuck? Betelgeuse? It's Betelgeuse. Pronounce it right. Betelgeuse. But anyway, look at this. I mean, I actually really, really think that these little diagrams are actually pretty good. The rings are punching up when they're on the northern side. They're acting very straight when they are near the red line. And the deeper they go, the bigger the ring is. That's great. And obviously, one thing that I see as when I was doing my geocentric debunking, right, was the fact that every single time the loop happens means 1 year. That's perfectly fine. That basically means, from our perspective, and they're trying to say that this has got some. This probably does have a little bit of stellar aberration in it, right? But when I see those rings, what I'm seeing in those rings is I'm seeing our orbit around the sun, right? So what I'm seeing is our position when we go around from one side of the sun all the way around to the backside. Our position is moving ever so slightly, and the star is wiggling, in our viewport, right? Basically, we are moving around the sun, and we are coming in front of it and behind it, in front of it, behind it, and so on and so forth. So, while still, fuck, I can't even fucking say it. While still Aberration, fuck, you know what I'm saying. It might deviate the light a small amount, but what I'm actually seeing is the orbit personally. Now, they looked at the AE map. And obviously, these lines are far too big for the AE map. But you notice how I don't really know how you as a flat earther you can kind of basically explain why the rings on the southern side are bounding out and the ones inside the grey zone are bounding in. And I mean, look at this grey zone, right? This grey zone is basically, it's all lopsided when it comes to the actual AE map, right? And so it's actually telling the AE map that there is a 23.5 degree tilt on the AE map. You're actually proving us correct here. This diagram is proving us correct. Thank you. Fantastic work, guys. Stop saying that it's a nail in the coffin for heliocentrism, because you've just debunked the AE map just then, right there on your map. And I was thinking about these loops, right? And so if you've got loops on the southern side and they are bounding outwards, right, to the outer rings, and you've got loops on the northern side bounding inwards, that basically means that stars that are on the south move outwards at certain times of the year, while the exact same stars in the northern side are bounding out towards the center. I would assume that when the actual loops cross, that would be the exact same time, because I would assume that is the case. Because if every loop is I would say in sync, then when they cross or when they're at the outer side of the loops, that would be the same timing. And so that basically means that from a perspective, that stars in the sky are moving away from each other and closer together, away from each other and closer together. Whereas on a globe, when they're on the southern side and we're on the northern side, they're looking at the star at the same parallel angles, right? And so when we move, we go from the bottom of the ring to the top of the ring, and to the bottom of the ring, and to the top of the ring. We would move in sync, whereas their loops on the AE map are stretching apart and pulling together, stretching apart and pulling together. I'd like to see what the actual particular dates are, and to find out whether or not that's actually in sync. But that says the AE map is not working. That's two things. That's two things that say the AE map is not working. Now, Stone said, globies are gonna freak out when we overlay this on the map, on the globe map. Now, I looked at this and I did not freak out. I'm sorry to say it, I did not freak out. I actually thought, bloody oath, it's about time. Look at that. All those lines line up with the plane of the solar system, right? Not necessarily the equator of the Earth, because the equator of the Earth is tilted on that axis, right? But the actual plane of all the solar system, with Mercury, Venus, Jupiter, Mars, all that sort of stuff, right? So all those stars are facing, all those stars on the southern end are bounding down according to where you are on that part of in that area of the map. And when you're on the top side, everything is bounding up. As far as I'm concerned, you guys have just proved the globe Earth. Well done, Stone. You've proved the globe Earth. You did not debunk anything. You did nothing. Now, I must admit that the distance was an interesting question, and yes, I can see that when I scale it up, it looks like the earlier period of the 20 years are a bit more longer, and it does close up at the end. Sure, there must be something interesting going on there. I must admit that when I looked at it, I think that the best way to measure this sort of stuff is actually when they do the crossings. So this measuring from one tip to a different tip, one's going into retrograde, the other one's going at full speed ahead. I would much rather see this measurement taken from every crossing. So whenever it reaches a point where the loop loops in on itself and crosses, that would be a much better indicator for each year. And I'll be interested to see each year how much percentage change it is per year. Now, I must admit that when I looked at all these charts, they went up at the start, and then they bound down at the bottom. And when you look at all of the maps that the charts that he had, all of them bound up and all of them bound down in the second thing. So there was something very, very consistent there. It was consistent, and so consistency is good. So whatever the case is, it's a good thing. Now, obviously, the 20 years does not look forward to this sort of thing. So I put the question forward that I did comment before I saw this, but I said, obviously, you're going to have to expand your time period to find out if there is changes in that 20-year thing, because obviously, if it goes up and then it goes down, well, you got to find out if it goes up again or if it goes down again. So you can either go from a ratio of, let's say it travels 10 miles and then it travels 9 miles and then it travels 8 miles and then it travels 7. You'd be going, okay, well, that kind of tells us that the average says that it's decreasing in its movements. Or if it goes from 10 miles down to 9 miles and then up to 10 miles and then up to 11 and then back to 9, well, then there's an interesting sort of wave pattern there. And that might be what's going on here. I can see that there's a wave, and it's starting to look fairly consistent when you look at 250 years, right? So obviously this 20-year assessment of this area is looking at when it was up in the high region and down the low region. So a better way to be able to draw this picture out is to find out what's the time period on this hump and what's the time period on this hump. Compare everything. You have to kind of compare it all as a math. And look, the thing is, if these waves were to continue on, and the question is does this all track out for the 26,000 years or thereabouts? Well, I mean, it's obviously they're just trying to compute it. They're trying to do their best estimation. So how can we 100% know exactly what year it is? We're just trying to use our data set that we have now and to extrapolate out. So it could be 25,000 years or it could be 27,000 years. We don't know until the data grows and grows and grows and grows, and you can get a better picture. But I have no doubt that if we found out exactly how far it has traveled in this like 130 to 140 plus years, when it goes from high spot to high spot to high spot to high spot and so on and so forth, and extracted on the actual distance that it will go around the pathway that it's choosing to from a globe Earth, does it travel? Will it take 226,000 years to get back to the start? If it does, you've just proved the heliocentrism again. So just saying, oh, it's wavy, oh, it looks confusing, is not a nail in the coffin for heliocentrism. It just means that we need to look deeper. I mean, if it's doing this, then you need to go out there and you need to figure out what is the distance that it's traveled over this particular amount of time, find out how far it has to go, and then find out how many more of these waves need to be added, and then find out how many years it's going to take. If we get 25,000 years, then everything's still kind of in check. So stop bloody hollering and saying that you won, because it's just, as far as I'm concerned, everything I saw looked fine by me. It looked just fine. Now, this reference was brought up for some sort of spinning top and saying that, there must be some sort of vector of gravity, which I must admit, you guys continuously bring up, parallaxes and gravity and all this sort of star charts and stuff like that. It's like, can you guys just talk about flat Earth for once? All you're doing is actually talking about globe theory, and you're actually not attributing it to flat Earth theory at all. Because I mean, do you actually have a solution at all from a flat Earth perspective as to why the stars wiggle the way they do over so many years? Do you have a solution as to why these stars have these loops? Do you have a solution for why there's waves over 250 years? Do you have a solution for why any of this is even possible? Why does it wiggle? Why does it not just stay where it is? Why does it not stay where it is? Why does it wiggle at all? Do you have a solution? Obviously not, because all you're doing is globe hating and not flat Earth proofing. I don't see any flat Earth proofs in any of these videos. It's always just globe hating. You guys have no flat Earth, creation. You haven't created any new narratives for flat Earth. You've only simply hated on globe Earth proofs. So this spinning top, they machine these things perfectly, right? The way that this Earth is, it's like odd shaped, and the thing about our Earth is that because of its ecliptic orbit around the sun, right? The fact that it's closer on one side in January and it's further away in July, right? What that does is that means that when it is accelerating towards the closer side, right, it will slightly get off its original path. Because of the fact that it has to speed up and it has to slow down, every single time it passes the perihelion, it actually is slightly in a different spot. And so there is, that slight movement every single time. Every single year, it's just a little bit different. It just moves around a little bit more and moves around a little bit more, all because of the fact that it's accelerating and deaccelerating, accelerating and deaccelerating. It's not a perfect circle. It's pretty close, but it's not perfect. And the fact that it's not perfect means that every single year it's just a little bit different, which can answer the question of why it is going in those slight waves, right? So its movement can bend because of the fact that it keeps on going around. Now, I tried to find a photo which would explain why it falls onto a new train track each time it goes around. It's kind of hard to find with the sun, but the moon does do this. So the thing about the moon is, right, is that because it's not quite, and of course this is accentuated, of course the fact that it's not a perfect circle, and that there is a high side and a low side, one where it's slow and one where it accelerates faster. Every single loop that it goes around, it changes its position just that little bit. And as you can see, this by this moon diagram here, it is always just a little bit further around each time, right? And so, what's to say that this 20 or 40-year cycle that you're showing in this is actually that small bend each time, and the general like cycle over the 26,000 years is the much larger full movement over the whole position. So a full twist of the sun of the earth completely, a full twist. But all of those waves could very well be when this particular recorrection happens, every now and then. So like all of these slight loops, you could get back to a similar loop, which was similar to the one you had 40 years or 50 years ago, right? But still the Earth has only moved, about like 5 or 10 degrees around. And so its alignment, with Polaris and the other North Stars, which keep changing all the time, changes that little bit more each time. But the general Earth will do that full cycle over the 26,000 years, and it will do the full set of loops over the 50 years. Is that possibly the solution? I'd like someone obviously smarter than me to actually tell me, whether or not they know what the actual cycle, of these actual, ecliptic orbits are. Because, to be honest, I don't 100% know, but this is highly likely the why you are seeing those waves. So I'd like to see this data. I'd like to see them up close. And as far as I'm concerned, one thing I'm going to leave with you from the perspective of the way I see, the geocentric argument, right, is that when I see distant planets like Saturn and Uranus and Pluto and stuff, just like the stars, their loops always seem to be roughly 1 year in cycle, right? And so when I looked at this chart ages ago, if after 1 year and maybe a few days, that's when most planets will realign with their loops again, right? The distant planets, not the ones that are close like Mars and Venus, they're too tricky because they got like cycles of 180 days or something like that. So it's too messy. They're like spinning like crazy. The ones that are really far away, like Pluto, right, that do like 200, 300 plus years in cycle, they only move a certain distance in our lifetime. Well, they do move a long distance, but from our perspective, they only do a certain amount of their actual orbit in the time between my birth and my death, they only move like a fraction of their actual orbit around the sun. And so when we see these loops that we see on these graphs, every single one of them is roughly 1 year, which is a sign that our orbit around the sun brings us closer to that planet and further away from that planet. Closer to that planet, further away from that planet. So we see the loops because we are getting closer and further away. It's us who keep on cycling in every single year. So when the cycle is 366 days, it's because we've traveled 365 and we've taken one extra day to get in alignment with it. So, yeah, that's my thoughts.